everyone, welcome to the series of line integral. Uh, in this video, uh, I'm gonna discuss about the question number 12 of line integral. The question is, so that f vector equals yz I vector plus zx j vector plus xy k vector is irrotational and find its scalar potential. This was asked in IOE TU 2058 post in BE Civil Computer IT and BSc and more. Uh, to show that vector is irrotational, we have to show that curl of f is 0. So curl of f is grad cross f vector. So this grad is I d by dx plus j d by dy plus k d by dz, and f vector is given in question as y z I vector plus j dx j vector plus x y k vector. Now it is cross product, so we write in determinant form this I j k over here, and del by del x, del by del y, and del by del z in second row, and in last row we write this yz yz zdx and xy. Now taking this, if we take this, then we have to cancel this column and this row, and it is this I vector, and by expanding the determinant we get del by del y of del by del y of xy minus this del by del z of zdx so it is I vector, so xy with respect to y, so x is constant, so positive x, and derivative of y with respect to y is 1 minus with respect to z, x is constant, so x, so it is x minus x is 0. Now for second j vector, we cancel this column and this row, and remaining is this 4. So remaining del by del x of xy minus del by del z of yz. yz, and this is del by del x, so del by del x of xy is y remaining constant, and here del by del z of yz, y remaining constant, and del by del z is 1, so this and this cancels, remaining is 0, and here is minus j vector, so minus 0 is also 0. So, and for this k vector, cancelling this row and this column, we have this 4, so del by del x of zdx and minus del y of yz, del by del y of yz. It is del by del dx of z dx. So the remaining is z is constant, so it is z and minus z. Here is k vector and also k vector. So z minus z is also 0. So uh, it is 0 minus 0 plus 0 is 0. So if curl of f vector is 0, then the vector f is irrotational. Now we need to find the scalar potential. Let that scalar potential be phi. So we have f vector is grad of phi. So taking dot product of their vector in both the side, we get this f dot dr equals grad phi dot dr, and f dot dr is this is f and dr is this. So f dot dr is I vector into I vector is 1, so yz into dx, that is yz dx, and z dx into dy is z dx dy, and xy into dz is xy dz, and this is the left hand side, and in right hand side it is grad of phi is I d phi by dx plus del phi by del y and k del phi by del z. There is, I think, j vector, and dr is, I have already told that I vector dx plus j vector dy plus k vector dz. So multiplying I vector is 1, so 1 into d phi by dx into dx is this much, and I vector into j vector is 0, I vector into k vector is also 0, and j vector into I vector is 0, and j vector into j vector is 1, so 1 into del phi by del y of dy, and the same is here, del phi by del z of this del z, and we can write this as del phi. Now in the left hand side there is yz dx plus z dx dy plus xy dz, and we realize that this is the same thing as dxyz, because if we expand this we get derivative of x and yz. Let this be u and this be v. So derivative of u dot v is u, and derivative of v plus v derivative of u, and again you can substitute it as u and v, so we get x and bracket this u derivative of v plus v derivative of u plus yz dx. So it is xy dz plus x into z. You can also write it as z dx dy plus yz dx. So yz dx, z dx dy, and xy dz. This can be also written as derivative of xyz. So now the final step is to integrate, and we get xyz plus c equals phi. So we can also write as phi equals xyz plus c, so that phi is the required scalar potential.